Quantum is a Latin word meaning how much. So a quantum of energy is a specific amount of energy. The rules of quantum physics state that an unobserved photon exists in all possible states simultaneously, but when observed or measured, exhibits only one state. Quantum mechanics is a mathematical framework for much of modern physics and chemistry and helps us make sense of the smallest things in nature, like protons, neutrons, and electrons. Complex mathematics is used to study subatomic particles and electromagnetic waves because they act in very strange ways. Quantum computers do not work in an orderly and linear manner like conventional computers. Conventional computers function according to binary logic, using ones and zeros and stringing together combinations of these. In contrast, quantum computing uses quantum bits or qubits, which are basically quantum particles such as electrons or atom nuclei. Quantum computers behave in a unique way because qubits communicate with each other through entanglement and calculate every existing possibility all at the same time. Qubits are placed in a state of superposition where they do not have values of 1 or 0, but both. In this way, quantum computing is one step further away from what's possible in the real world because qubits can be in more than one state at any one time. Currently, the development of actual quantum computers is still in early stages. Practical and theoretical research is continuing, and many governments and military agencies are funding quantum computing research in an effort to develop quantum computers for business, trade, civilian, and national security purposes, such as cryptanalysis. In theory, data transfer in quantum computing will be many millions of times faster than conventional computing. This will redefine how we communicate. There is already a relatively high amount of distrust over questions of privacy and security, both within and between nations and governments, which is only expected to rise, further increasing frictions and therefore competition between states. It is highly likely that when functional quantum computers do exist, some governments will speed up investment for computers that can rapidly decode data. At the same time, this competitive situation will leave behind those countries that are less resourced, thus widening an already stark digital gap. This possible future has a wide range of security and social implications.